So welcome students, we have already covered the all syllabus from this course. Now from today I will repeat the whatever I have already discussed before minor. Okay, so today I will discuss about the introduction of membrane technology. So what is the membrane? So membrane is a thin film which allows to some selected components to pass through it. So basically it is a separation media. So if you have a feed or if you have a mixture of different species, so what membrane do? Membrane will allow some of the molecules to pass through it, and some it prevent to transport of the some of the molecules. So it is a type of separation media. So membrane might be a solid, membrane might be a liquid, or membrane might be a gas. So it may present in any physical phase, or there are different types of membranes. Membranes might be the homogeneous membranes, heterogeneous membranes, symmetric or asymmetric membranes. So we will discuss about the different types of membranes in the next few classes. So now we'll come about the advantages of the membranes. So if we compare the membrane based separation technology to the other conventional separation technologies, so membrane based separation technologies have the several advantages. So few are written here. So first important advantage is generally membrane based technologies works at a room temperature. If you compare membrane based technology to the other technologies like distillation or uh, other crystallization or evaporation, then membrane based technologies generally works like reverse osmosis works at the room temperature. If you use the evaporation for water purification, then you need the energy, a large amount of energy to change of the phase, or it will work at a very high temperature. Second advantage is the less energy requirement, because you work the membrane based technologies work at a room temperature, so it required the less energy. If you this is the comparison between the evaporation for water separation, water purification, with the reverse osmosis. So if you do the open pan evaporation for water purification, the energy requirement is 600 kilowatt per 1000 kg of water. If you use the multi-stage evaporator, 5 to 7 stage evaporator, then energy requirement reduced to 37 to 53 kilowatt per 1000 kg of water. And if you use the reverse osmosis, the energy requirement will be the 5 to 20 kilowatt per 1000 kg of water. So basically the energy requirement in the membrane based technologies are much lower in comparison to the other processes. Third advantages is the no phase change. So when the because in this process we work on the osmosis. Basically if you look to the water purification process, so we work only on the principle of osmosis. So that's why generally we are not using the phase change. Only in per operation process we do the phase change. So when the phase does not change, then you need not to give the energy to the in the process, much energy to the in the process. So due to the phase change, generally in the different separation process where the phase change occur like distillation, so due to the phase change you need a lot of energy, because you have the energy of vaporization or energy of condensation or energy of crystallization. So these are the energies which required during the phase change. So in this process you need not require any type of phase change energy. Now the next advantage is less space required. While less space required because it is a surface based phenomena. So membrane based separation is basically surface based phenomena, and you can accumulate a lot of membrane surface in a small volume by using the specific geometry. So we will that is called the membrane module. So we will discuss about the membrane modules also. So in the membrane based phenomena we can accumulate a large amount of membrane surface in a small volume. So it required the less space, as well as because we are not using the phase change. That's why we are not we need not to use the other phase change equipment. Like in the distillation column you have to use the reboiler, you have to use the condenser for the phase change. But because in this process you don't have any this type of phase change, you need not to require to use that type of equipment, so your space requirement will reduced. Next is the non-reactive process. So this is the separation process, non-reactive separation process. So reactive separation process like the chemical adsorption or chemical absorption. So what's happened in the reactive process is the some of the material will be consumed during the reaction. So your recovery will be less, or you will lose some of the molecule permanently, some of the component permanently. But in this is a membrane based process, is a physical process, so it will divide feed system in the two separate stream. One is the product stream, one is the rejected stream. So your product component will be enriched or concentrated in one stream, and their concentration will be reduced in the other stream. So this is the advantage of the membrane based process. Now it can operate in the continuous manner, because you need not to regenerate the, if you compare this process to the adsorption process or absorption process, in that those processes you have to regenerate the absorbent or adsorbent. But this is a the membrane based process, you need not to regenerate any type of absorbent or adsorbent, so this can be operate at the continuous manner. Now, next is less operating and capital cost. Due to these above mentioned advantages, the core cost requirement is the operating cost requirement will be reduced. Why? Because your phase change is not required, the energy requirement is low, the space requirement is low, so your you need the lesser operating cost, as well as because you are not doing the phase change, your other equipments are not required. As I told earlier that you did not do not require the condenser or the reboiler in this process. So the requirement of the capital cost is also low in this process. So these are the advantages of the membrane based processes. Now this is some disadvantage of the membrane based processes. So in most of the membrane based processes you cannot achieve the 100% purity. So this is a disadvantage, because membrane can only partially separate the material. So it can resist a molecule to pass through it, but that resistance will be not 100%. Every molecule can pass through the membrane, or membrane might have some defects also, some holes also. So in large if you are using the membrane in the industrial scale, so you cannot achieve the 100% separation. Or in some of the process it is very difficult, because the molecules are similar in shape. Like I have already discussed the gas separation. So in gas separation the molecules are similar in shape, so you cannot achieve the 100% separation. In the some of the process like reverse osmosis, you can achieve nearly 100% separation, but not the 100% separation. So purity is not achieved, or if achieved it is costly. So if you are achieved the purity, that means your membrane will be very high, very expensive. So this is a disadvantage of this process, you cannot achieve the 100% separation. Second disadvantage is cannot be operated in the extreme environment. So if you cannot, because the membranes, most of the processes, membranes are the polymeric membranes. So polymeric membranes has their own limitation based on the physical properties of polymers. So generally polymers cannot be used at like above 100 degrees Celsius or above 150 degrees Celsius. That is the one limitation. Second is about with the pH values, you cannot use the membrane at very low pH like less than 4 pH or less than 5 pH. You cannot use the polymers about 10 pH. So this is also a limitation of the membrane based processes. So it cannot be operated at the extreme environment. So this is a limitation. Even the chlorine is also a limitation for the membrane based process. Any other foulant may be the limitation of the membrane based processes. Third is the fouling of membrane take place. So with time what's happened, if your feed contains some micro particles or other things, or you are using for membrane for the biological system that contains the microorganism, so that may be grow on the surface of membrane, or the particles may be stuck in the pores of the membrane, so that may leads to the permanently decrease of the fluxes. Okay, so flux will be decreased permanently with time, so that is called the membrane fouling. So fouling always take place in the membrane, so you need not, you are required to replace the membrane after some time. Generally the time is sufficiently large, like in the reverse osmosis you have to replace the reverse osmosis cartridge after 1 year or 2 years. So this is the membranes cannot be worked infinitely. You have to replace the membranes due to the fouling. Second is the concentration polarization. So concentration polarization is a phenomena which occurs in the membrane based processes. So what's happened, like you have the, this is a schematic diagram of a membrane based process. You have the feed, that is the rejected by stream, and across the membrane you have the permeate stream, which is the product. So suppose you are separating the water salt solutions, you are purifying the water. So here you have the concentrated salt solution as a feed, and the water will be permeates through the membrane. Salt cannot be permeated through the membrane, and here you will get the concentrated salt solution, and here you will get the purified water in the permeate side. So what's happened, because membranes the membrane can only be water molecules can only pass through the membrane. So the concentration of salt will start to increase at the surface of the membrane. That due to the higher concentration, salt start to then diffuse at the opposite direction, okay, of the flow. But so what's happened, due to the higher concentration, the actual driving force in the membrane based process generally depends on the two factors. One is the pressure difference, second is the concentration difference, because both factors will affect the osmosis. So the due to the higher concentration of salt at the surface, the flux will be reduced. That is called the concentration polarization. Concentration of salt will be polarized at the surface of the membrane, okay, because membranes are membranes are selective for the water only, okay. So that the salt will not deposit on the membrane. If it is deposited on the membrane, then it will called the fouling. It is not called the concentration polarization. In concentration polarization, the concentration of salt, it will be still in the soluble in the water, but the concentration of salt will be higher. Like here, if the salt concentration is 500 ppm, here it might be the 2000 ppm at the surface of the membrane, okay, and then it will start to diffuse at the opposite direction towards the 5500 ppm salt, okay. So the concentration will be high, so you will get the flux, you will get the water. It will not deposit. If it will deposit, then you will not get any water. So it will not deposit on the surface of the membrane, but it will, the concentration will be higher, which will leads to the reduction of fluxes. So this phenomena is called the concentration polarization. So due to the concentration polarization, you have the lower fluxes in the membrane based processes. Now some of the marine materials, basically a lot of membrane polymeric materials can be used in the membrane based processes, but there are some polymers which are quite famous and which are used widely in the commercial membranes. So these are the some of the materials. So in the polymeric membranes, we can use the cellulose acetate, then polysulfones, polyamides, polycarbonate, polyacrylonitrile. So these are the polymeric based membranes which are commercially available. And in inorganic membranes, you can use ammonia, you can use zirconia, you can use stainless steel, carbon composite, and silica. So these are the membranes which are used in the inorganic type membranes. Inorganic membranes can be used up to the 100 degrees Celsius, but the limitation is the selectivity of the membrane. So we will discuss about the inorganic membrane detail in the next in the other classes. So these are the basic polymeric materials which are generally used in the membranes. So in the reverse osmosis, or where you want to separate the water or you purify the water, you need some hydrophilic membranes which can easily allow to pass the water through it. So for that case, you can use the polycellulose acetate membranes and polyamide membranes. For the ultrafiltration, where you want to separate the particles from the membrane, you can use the polysulfones membranes. Polysulfone ultrafiltration membrane are also used as a base or as a support for the polyamide or polyacetate reverse osmosis membrane. Why? Because polysulfones has the very good strength, mechanical strength, okay. So basically the polycarbonate and polysulfones membranes are used as a used in the membrane processes because it has the good mechanical strength. Now the working range of different type of membranes. So this here we explain the temperature limitation. So cellulose acetate membrane can be used up to 40 or 50 degrees Celsius. The polysulfone and polyamide membranes can be used up to 80 degrees Celsius, and ceramic membranes can be used 130 or even the 500 degrees Celsius. Nowadays, the membranes are ceramic membranes are available which can work up to the 400, 500 or 600 degrees Celsius. Now the pH limitation. So the pH range, the working range of pH for the cellulose acetate membrane is quite lower. It is around 6 to 8, which is the range of pH of water, processed water. So basically cellulose acetate membranes are used for our in the reverse osmosis for water purification. If for polysulfones and polyamide, the range is quite large, bigger. It may start from the 4 to like 8 or 9, and for ceramic membranes the range will be quite bigger. So it may like 2 to 12 around. Okay, so this is the pH range of the different types of membranes. Now the chlorine limit, because the municipal water also contains the chlorine which may degrade the polymers, so there are chlorine limit for the different type of membranes. For polyamide membranes, chlorine limit is, chlorine resistance is quite lower. It is less than 1 ppm. For cellulose acetate membrane, it is around 10 ppm, and for polysulfones membrane it is around 13 or 14 ppm. Okay, so the chlorine limitation is also important factor, because the municipal water several times contains the significant amount of chlorine. So it may basically it may degrade your membrane, or so that's why we are using the carbon cartridge in the domestic membrane based separation process which we use, or the domestic reverse osmosis unit which we are using in our homes. So that contains a carbon cartridge for removing this chlorine. So because if the direct we use the use the reverse osmosis process for the water purification of municipal water purification, so the membrane will be degrade or decompose very quickly due to the presence of chlorine. Now the solvent stability. So all four types of membranes, cellulose acetate membranes, polyamide membranes, polysulfones membranes, and the ceramic membranes, all are stable with water. So basically these two membranes, cellulose acetate and polyamide membranes, are specifically used for reverse osmosis for water purification. Other membranes are used in the different processes also. So other as polysulfones membranes are also quite stable with all solvents, except only the butanol, so it is not stable for butanol. Ceramic membranes are stable with the acid also, alkyl solution also, butanol, ethanol also. So these are the quite stable membranes. Now various membrane based processes. So there are different types of membrane based processes which are used for specific purposes. So basically these are the main processes, and these are the driving force used in that processes. Driving force means the force required for mass transfer, the force required which act as a which drive the material to pass across the membrane. Okay, so this is the driving force. So so there are 4 different types of membrane based processes which are especially used for water purification: microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. So these all 4 processes, in these all 4 processes, driving force is pressure. Okay, so these all four are working specifically on osmosis based separation, or pore size separation, or pore flow separation, and the driving force in these processes are the pressure. In the dialysis, driving force is the concentration. Electrodialysis, driving force is the electrical potential. Liquid membranes, driving force is the concentration concentration. And peroperation, driving force is pressure and temperature. And gas separation, driving force is pressure. So I have already discussed most of the processes in this course. So basically the driving force, and that during the explanation of that processes, I also mentioned the driving force. So these are the driving force. Now basically we will also focus on these 4 processes, because these processes are used for the water purification. The basic difference between the nanofiltration, the reverse osmosis, nanofiltration, ultrafiltration, and the microfiltration is the basically the pore size. So pore size will be very less in the reverse osmosis, so it is used to separate the salt. Nanofiltration, pore size is a little bit larger, but surface has the positively charged, you have the membranes are positively charged at the surface, so it will repel the ions, especially the metal ions. Okay, so in nanofiltration you can repel the metal ions. In ultrafiltration, the pore size is higher than the nanofiltration, so it is used to separate the bacteria, virus, or as well as it is also used to separate the different type of proteins in the in different type of proteins in the biotechnology or the food processing industry. You can use it to the concentration of proteins or concentration of biological materials. Microfiltration are used for removing the microparticles or the suspended solid particles from the water stream or the from different type of streams. The size of the pores in the microfiltration is largest, and it is in the micro size. So this is the different type of processes used in the different type of membrane based processes. Now membrane functions. So apart from separation, membranes are also used in the different operations. So membranes can be used as in the separation, which is the most important process. So you can separate out the smaller size of molecules, or you can separate out the specific molecules in the membrane. Second application of membranes is as a contractor. So what's happened, because membranes are used for membrane based processes is a surface phenomena. So it provides a large surface. You can accumulate a lot of surface in a smaller space in the membrane based processes. So it can act as a contractor for the two different streams. So like you have the liquid, you have the water, you want to increase the contact between the liquid and water in a reaction. So it is a heterogeneous reaction where you have a liquid, you have a water, you want to increase the surface area of the contact. So you can use membrane as a separator for the liquid and water. So what's happened, that membrane will provide the very large contact area for liquid and water. Otherwise only the bubbles of gas will produce in the membrane or in the water, and with that or in the liquid, and that will be the very less surface area. So you can increase the surface area by using the membrane. So in the if you have the membrane based reactor, you can also coat the catalyst on the surface, which will also act as a contractor or increase the surface area of the membrane. Now immobilization in the different biological processes, you can use the membrane as a immobilization. The required molecules can be trapped inside the membrane and it will be immobilized. Now membranes are also used for control release, because it is a membrane is a in the membranes only the mass transfer from the solid membranes is very slow process. So you can membranes can be act as a control released medium. So nowadays membranes are also used for drug delivery, as well as this phenomena is used in the membrane reactors, where you need the you want to feed a type of reactant in a controlled manner. Okay, so there you can use the membrane as a controlled release media. So I have already explained this in detail during the membrane contract reactor chapter. Now the function of membrane for the membrane filtration, as I have already explained you, there are 4 different processes which can specifically used for water purification: microfiltration MF, ultrafiltration UF, nanofiltration NF, and reverse osmosis RO. So these 4 processes are used, and RO have the pore size in the 10 to the power minus 10 meter or 0.002 meter. It is in the molecular the pore size in the molecular range. So it can only allow to pass water, but it will reject the all different type of other material. In nanofiltration pore size is less than 1000 nanometer. It is in the nano range. The pressure requirement is 5 to 35 bar. In reverse osmosis, pressure requirement is much higher, 5 to 150 bar. In nanofiltration, it is lower, 5 to 35 bar. So it will allow to pass the water as well as monovalent salts. So monovalent salts like NaCl or CaCl2, which are not poisonous for the health. So it may not resist this salt because it is the porous membrane. So it cannot register salt, this type of salts which has the single charge as well as the small size of the molecule. So that type of salts cannot be separated out from the nanofiltration membrane. But in the nanofiltration membrane, surface is positively charged, so it will reject the heavy molecular weight salts like mercury, like lead, like chromium. That type of heavy molecular weight salts or heavy metal salts can be rejected by using the nanofiltration membrane, and these salts are poisonous. So nanofiltration membranes are especially used for wastewater treatment in the different type of industry where these salts are present in the water. So if you specifically want to remove the chromium salt or zinc lead salt or this mercury salt from the water, you can use the nanofiltration membrane. Then the ultrafiltration membrane, the pore size are much larger, the pressure requirement is much lower. So in the ultrafiltration membrane, you can only separate out the virus or bacteria from the system. Ultrafiltration membrane has the other application also in the food industry or the biotechnology for the separation of the different types of or different size of proteins, or separation of different type of sugars, or separation of or the concentration of this material or concentration of microparticles. So there also we can use the ultrafiltration membrane, but the basic application of ultrafiltration membrane in the water purification is to separate out the virus and bacteria from the water. So the before the reverse osmosis processes, we also use the AquaGuard in our homes. So AquaGuard system contains only the ultrafiltration membrane, because the AquaGuard cannot reduce the TDS of the water, but it will separate out the harmful bacteria and the virus from the water. So in ultrafiltration membrane, we use the we can separate out the virus or the microorganisms from the water. Now the microfiltration membrane. So microfiltration membrane, generally all different types of salts and microorganisms can be passed, but it can resist with some big size of bacteria as well as the suspended solid. So this is generally the microfiltration membranes is the pre-requirement of this type of membranes: ultrafiltration, nanofiltration, and reverse osmosis membrane. So before going to the higher separation, we will use the microfiltration membrane to separate out the suspended solid. Otherwise this type of solid and bacteria will foul the other types of membranes like reverse osmosis membrane or nanofiltration membrane. So we have to separate out the big size of bacteria or fungi and as well as the suspended solid from the water. So for that we will use the microfiltration membrane. So you should remember about the pore size as well as the pressure requirement of different type of membranes, and which type of salts can be removed from the which type of membranes. So in next lecture we will discuss about the types of membrane.